Now let's use both Kirchhoff rules for a multi-loop circuit. Okay, so we're going to draw one here that has, let's say, one battery here, and it comes up, resistor 1 there, and then it comes down and over, and say another battery, EMF 2 there, and another resistor, R2, and then it splits and comes down, and yet another resistor, R3. So this is one that you can't just look at and apply Ohm's law to instantly solve. It requires something a little more complicated. We need to apply our two rules. So first, let's think about the junction rule. So there's a couple of junctions here, one here and one here. So let's first define the currents. So I1, we'll say, is going to flow out of that first battery, go all the way till you get to here. That's the first junction. Then we need to split it up and say I2 goes there, and let's say I3 goes here. I'll draw it over here. And that defines all the currents. So here it's I1, here it's I2, 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 back to I1. And then here it's I3 all the way across here and back to I1. Okay? So the junction rule. You can pick either junction. We can pick this one and say I1 goes in and I2 and I3 go out, just like we had before. So I1 equals I2 plus I3. That's one equation. Now, what are we really doing here? Let's stop and think for a second. We're trying to find the currents in a problem like this. I'm doing it all symbolic, but what you would imagine is you were given a circuit with resistors and batteries in it. So say this is 12 volts and 10 volts and 10 ohms and 20 ohms and 50 ohms. What we're trying to solve for is the current in each branch. So we have three unknowns. Right here. There's already one equation. We know if we have three unknowns, we need three equations. So from the loop rule, we need two more equations. You might say, oh, we could get one more from the junction rule by looking at this junction, but that would be another case. That would be a case where you already have the same information. It wouldn't tell you anything different from this junction. So we have to go to the loop rule to get two more equations. All right, so for the loop rule, we've already defined the current directions. All we got to do is say, what loop are we going to do? There's actually three loops here. We could do this loop, the top half. We could do this loop, the bottom half, or we could do the outside. Right? So three possible loops. Let's start with the top half. Let's just go around it clockwise. It's always good to go clockwise. Let's start here. Okay, I'm a positive test charge. I'm going with the current. I encounter R1, so it's minus IR. So in this case, it's minus I1 R1, because I'm going with I1. So minus I1 R1 is 1 delta V. And I'm still going along, going along, going along, going along. And I come here. And now I go across this battery, but I go backwards across the battery. I go from the high potential to the low potential. So that's minus EMF 2. All right. And then I cross the resistor R2, and I'm going with the current I3. So that's minus I3 R2. And then in this loop, I go across the battery EMF 1, and I'm going from the low to the high, like you would expect. So it's plus E2 equals 0. So there's a loop. Now let's see. So that's two equations with our three unknowns. We just need one more equation. So let's do this bottom loop here. Okay, we're going to go clockwise around the loop. I'm going to start here. Here we go. Let's see, we're going this way, going this way. We're going to go across R2, and we're going against current 3. Yeah, so that means it's plus. Right? We're going against, we're going from the low side to the high side. So that's I3 R2. All right. And then we're going to go against, or we're going to go sort of with, from the low to the high of the battery, EMF 2. So that's plus EMF 2. And then we're going down across, here we go. And now we're going with current 2 across R3. So that's minus I2 R3, minus I2 R3. And then, oh, we're back where we started, so equals 0. So that should actually solve it. There's 3 equations, 3 unknowns. Here's one, I1, I2, I3. There's an unknown, 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 and unknown. All the other terms are known. You're going to be given a circuit with EMFs and resistances. And then it's just down to algebra, or if it's really complicated, linear algebra, to solve for the 3 currents. Generally, in sort of a freshman physics class, you'd be given circuits where it's doable by hand. That's usually what we hope for. It's not so simple that you can't mess it up. You can end up in your own little loop and never find the answer. So we're going to do an example for you with real numbers plugged in.